Okay, where were we? Where were we? We were here. And home. Okay, the snow day and then no school Friday because of the vaccine threw me off just a little bit. Originally, the test was, and I can't remember if I told you guys or not, or if it was the other classes, Wednesday and Thursday. We got to have it Thursday and Friday. So we got to get through section 5, 6. If I don't get to a little bit of material, I'll just exclude it from the test. But we got a test on Thursday and Friday just because I don't want to wait till after President's Day, which would be a Tuesday, and then push that back 2 additional days. So we'll work it out. I don't know if we'll get through 5, 5 in 2 days or 3 days, but then we'll cover 5, 6, and then we'll review. But just Thursday will be no calculator, and you will have some problems like we just had on there. And then Friday will be calculator. You will need to know all 6 graphs from negative 2 pi to 2 pi. Now, we've only done 2 so far. We've only done sine and cosine. Today we're going to do tangent and cotangent. All right, for tangent, I'm going to do something different this year. I think we're just going to start with the graph. Okay, you are going to have vertical asymptotes at these spots. Go ahead and your scale should be pi over 2. And so obviously the far left will be negative 2 pi, the far right will be positive 2 pi. And go ahead and draw in those vertical asymptotes. Did you get that ticket code?
No, not yet.
I just sent it to your phone.
Oh. Okay, then yes, I did. Thank you. Oh. Is this like a text?
Yeah.
Shouldn't tell her, huh?
Today's at 7 a.m. I already reset something.
I don't know. It just says 12%.
It doesn't come through.
Okay, thank you.
All right. So between the asymptotes, here's what's going to happen. Tangent of negative 45. Now you got to watch. I'll keep reminding you this, but you got to remember whether you're in mode, radians or degrees, based upon what you're doing. I'm just going to keep it in degrees just because it's simple for me. So tangent of negative 45 is negative 1. That is negative pi over 4. That's going to be halfway in between 0 and negative 90. That right here is going to be negative 1. What's the tangent of 0? Tangent is 0 degrees. Oh, I see Hess thinking. Or he's just getting ready for the academic challenge match. I'm not sure. All right, what's tangent of 0 degrees? I won't put anybody. It's 0. So we get that right here. And what's the tangent of 45 degrees? Tangent of 45 degrees. Hopefully you remember that one. Positive 1. Okay. So these are our 3 key points. Now here's what's going to happen. In between these asymptotes, it's going to look like that. Okay. It's going to go from negative infinity up to positive infinity. You are going to get that same shape in between each set of asymptotes. Okay. As you move left to right, it'll go from negative 1, like halfway in between. In this case, it'll be 135 degrees. 180 will be 0. And at 225, it'll be positive 1. And so it will continue that same shape. Now from 3 pi over 2 to 2 pi, we only get half a branch. Now, yes, it does continue, but your responsibility is only from negative 2 pi to 2 pi, so it'll just be that left piece. So I will stop it right there. Yes, it does continue past 2 pi, but if we are stopping it at that point, you only get that piece there. And same thing to the left here. As you move left to right in each interval, you will get a branch, and same thing here. But we'll just get this piece there. All right, there's your tangent graph. Now I have my window set from negative 360 to 360 because I knew I was in degrees. But if I go y equals, and I got tangent of x, and I hit graph, okay, I get that shape. Okay, I get 3 what I'll call full branches, and then you got 2 half branches on the left and right. What's the period? I think that's the first thing you got down there, right? What's the period of this graph? Make sure you really understand what that means. Cooper, do you know?
I'd say pi.
You'd say pi, he's correct. That is where it starts to repeat. Each branch is unique, and then it starts to repeat. So basically from negative pi over 2 to pi over 2 is our period. I got mine in a different order for some reason, but it is pi. What's the domain? Not all real numbers. This is kind of a hard one how to word it. We'll start out with all real numbers except all real numbers except what? Well, every time there's an asymptote, so there's going to be an asymptote of pi over 2, there's going to be an asymptote of 3 pi over 2. Morehead, what do you got?
Pi over 2x.
Huh. Where x is what?
A whole number.
No, because what if x is 2? What's pi over 2 times 2? That would be pi, right? So yeah, this is a hard one to really work. And sometimes you can do it that way. Typically, here's how this is worded. All real numbers except odd multiples of pi over 2. Okay, except odd multiples. Now that gives you, if it's an odd number, it has to be an integer. So odd multiples of pi over 2. And so yeah, this is kind of difficult to phrase it. Range, what's our range? Hold Luca. All real numbers, obviously. Negative infinity to infinity. And even or odd? Even or odd? Go rows. Can't use your calculator for that.
Odd.
Odd. It is odd. Why is it odd?
Whenever you plug in, let's say like tangent of 45 and tangent of negative 45,
Mm-hmm.
you don't get the same point.
Correct. And now you got to get, and actually you got to take one step where you got to get opposite points. So 1 and negative 1, or square root of 2, negative square root of 2. But yes, it is an odd function. All right, we're starting to get it. It is an odd function because tangent of negative theta is equal to the opposite of tangent of theta. Like you can pick, and since I'm in degrees, I can pick tangent of 145. Whoops, I forgot the 1. 145. Okay. It's some decimal. What's the tangent of negative 145 have to be? Okay, if it's an odd function, it has to be the opposite. Same answer, but opposite. Okay. All right, now you got the graph. Why does it look that way? Let's take a look at that for a second. Tangent is sine divided by cosine, right? We learned that. Now the sine function is your red graph, cosine is your blue graph. Wherever cosine hits 0, it has to be undefined. Okay, so it is undefined at pi over 2, it's undefined at 3 pi over 2, at negative pi over 2, and at negative 3 pi over 2. We want to take a look what's happening in between just 2 of those. So we want to take a closer look. All right, so this is from negative pi over 2 to pi over 2. Okay, sine is our red, and cosine is our blue. What's happening as we get close to 90? Sine is getting closer to what? Sine is getting closer to what at 90? I'm looking. What's the sine curve approaching at 90 degrees?
1,
1. What's the cosine curve approaching at 90 degrees?
0.
0. So this is getting close to 1. This is getting close to 0. So let's take a look at 80 degrees. So if I take the sine of 80 degrees, it's a 0.984. What's the cosine of 80 degrees? 0.17. Okay, now the tangent is I divide those. So what's the tangent of 80? If I just hit tangent of 80, it'll give me the division, 5.67. What's going to happen as this number gets closer to 1 and this number gets closer to 0? What's going to happen to the division? Is it going to get bigger or is it going to get smaller? Or not even, no idea. So bigger or smaller? Bigger. It's going to get bigger. Even though there's small numbers, this is getting very, very close to 0. So let's go to tangent of 89. Whoops, hold on. Let's go sine of 89 first. It was 0.984, now it's 0.9998. What's cosine of 89? 0.017. So now what is the tangent of 89? 57. So as we get closer to 90, it's going to get bigger and bigger. What's the tangent of 89.5? 114. What's the tangent of 89.8? 286. So it's going to go to infinity. Okay. Now, but what happens at 90? Tangent of 90 comes crashing down. Okay, doesn't exist. So this is what's happening. Over here, this is a negative number. This is a positive number. That's why this goes to negative infinity. Okay, and at negative 45, it hits negative 1. And at positive 45, it hits positive 1. So this would be the tangent graph. All right, there's a little bit as to the y. And then it just kind of repeats that pattern. All right, cotangent. The asymptotes switch. They're not the same spot. And now also 0 has an asymptote, and I will do my little crosshatches here. All right, so draw in those. All right, I want you to think what it looks like. It's not exactly the same, so just draw exactly the same if we want. But think what it looks like. We're going to get similar to it. But, and I'll come back to this in a second. Cotangent is cosine divided by sine. Sine equals 0. Or it's undefined where sine equals 0 at 0 radians or 0 degrees, and then pi or 180. Cosine is getting close to 1. Sine is getting close to 0. As it's near 0, is it going to positive or negative infinity? Okay. Since these are both positive, it's going to positive infinity. It's going to equal 0 where cosine is 0. And then we're coming here, it's a negative divided by a positive. So it's going to go to negative infinity. So we're going to get a flip of the direction. Because the other one went from low to high. This one's going to go from high to low. And at pi over 4, it's going to hit 1. Pi over 2 is going to hit 0. In this case, it's 3 pi over 4, but halfway in between, it'll hit negative 1. So it's going to look like that. So it's going to snake through there, but it's going to flip directions. It's going to go from high to low. And then that is going to be repeated in between every set of asymptotes. Okay, so right there, here, here. And it always hits 1, 0, negative 1. From left to right. Positive 1, 0, and negative 1. Okay, period. Once you got that down, period's gonna be the same as it was for tangent. It is pi. Period is pi. Domain, all real numbers except. Okay, except all we have to do now is go 0, pi, 2 pi, 3 pi. So it hits all the integers. So except integer multiples, all real numbers except integer multiples of pi. So you could say pi x where x is an integer. Okay, like that. Like Ryan was talking about earlier. Range negative infinity to infinity. And this one is an odd function again. Cotangent of negative theta is equal to negative cotangent of theta. Okay, they're going to be the opposite for that one. All right, what's next there? Okay. These do not have an amplitude. An amplitude is a high point and a low point. When you have a constant in front, it's going to stretch it. Okay, so right here, your vertical stretch or compression will be determined by that A value. Okay, so now we don't have a high point and a low point like sine and cosine. Vertical, the period is pi divided by B because the new period is not 2 pi anymore, it's just pi. So make sure you know the difference. Sine and cosine is 2 pi divided by B, tangent is pi. Phase shift is still C, vertical shift is still D. Okay, so those are all those key components when we're doing transformation. All right, flip it over on the back. Let's take a look at one here. We're going to graph this over a 2-period interval. So write that equation under where it says y equals. I got a little bit more information on yours than I got up here on mine, and I'll fill it in though. Usually with tangent and cotangent, I'm going to ask you to graph a 2-period interval, basically 2 branches. Okay, 2 branches of it. We're going to find all the values for one branch, and then we're just going to slide it over. All right, so what does it ask me for? Vertical stretch. Vertical stretch. And that will equal 2. Here's what that does. Easiest way to think about that is if I go back to my tangent graph, it usually hits at 1 and -1. So those points will now be what? 2 and -2. So it gets stretched up. All right, so sometimes it's hard to see. It looks exactly the same, but it does get stretched up. What else we got? Vertical stretch. Period. Period is pi divided by 1/2, which is 2 pi. Okay, so now each branch, you'll take a distance of 2 pi to do a branch. And phase shift, which way is this thing moving? Phase shift. Left pi. All right, here's how we're going to do this. And there's different ways. Like some people can figure this out and they can say, all right, it's shifting this way. I've compressed it or stretched it. Here's where everything's going to be. That's really hard. Okay. If you're really good and you're with spatial, you can figure that out. What we're going to do is we're going to find 2 adjacent asymptotes. So we're going to find where these asymptotes have moved to. Okay. And find their new position. And then we're going to find these 3 points, okay, between them. So but we got to find the asymptotes first because they're not going to be, in this case, they're not going to be in the same spot because we've changed the period and we've shifted it. So what's it say on yours? It say asymptote number 1 and asymptote number 2. Okay. So for tangent, so for 2 adjacent asymptotes. Okay, for tangent, use the asymptotes at negative pi over 2 and pi over 2. So those are the ones that we're going to see where they move to. Okay, we're going to start with negative pi over 2 and pi over 2. All right, here's how we do those. So for the first one, asymptote number 1. Okay, if this was just tangent of x, the first asymptote would be a negative pi over 2. This is going to affect right there where it moves to. So what we want to do is we want to take that and you want to set 1/2 times x plus pi equal to negative pi over 2. That's how you get the first asymptote. And you solve it for x. And whatever that x value is, that is where that asymptote is now moved to. Okay? And now for asymptote number 2, you're going to take 1/2 times x plus pi and set it equal to pi over 2. Now I like to move from left to right. That's why I did this one as negative pi over 2 and that one's pi over 2. Solve it for x. That tells you where your new asymptote is. All right. Solve the first one for x. See what you get. And I'll go through it with you in a second. But just watch your algebra. All right, you should get negative 2 pi. Negative 2 pi. Now you can do it a couple different ways. I'm going to get rid of this 2 1/2 by multiplying by 2. Some of you distributed the 1/2, it doesn't matter. But if I multiply by 2, I get x plus pi equals, now those cancel, I get negative pi, subtract pi, and I get x equals negative 2 pi. You should be able to kind of have an idea where the next one is based upon the period. What is the period of this one? Okay, Cooper, what's the period?
2 pi.
2 pi, so the next asymptote has to be 2 pi away. Now, I like to go through the math anyway just to make sure I'm doing everything right. So I'm going to multiply this one by 2. I'm going to multiply this one by 2, and I get x plus pi equals pi. And when I subtract pi, I get x equals 0. Okay, so that's where my asymptotes are. And it should make sense that they are 2 pi apart because that's now my period. All right, so now I think you have, I got asymptote number 1. Now what do I have listed next? 0.1, 0.2, 0.3, and then asymptote number 2, right? I think I accidentally put asymptote number 1 twice. That should be asymptote number 1. All right, asymptote number 1 is x equals negative 2 pi. Asymptote number 2 is x equals 0. All right, how do I get those points in between? Very similar to what we did to sine and cosine. If you think about this, let me go back to tangent. I am really dividing this into 4 equal intervals, okay, in between the 2 asymptotes and these 3 points. So take your period and divide it by what? 4, and that's what you're going to add. Take your period divided by 4. And my period is 2 pi here. So you want to add the period divided by 4, which is 2 pi, divided by 4, which is pi over 2. So you're going to add pi over 2, and that's going to give me negative 3 pi over 2. What's going to be the y value? Now remember, tangent goes from low to high, and we was also stretched. At that quarter point, that's kind of like called a quarter point. It's all usually -1, and then the next one's 0, then the next one's 1. So this one's going to be where?
-2.
-2. So it's going to be down at -2. -2. Go another pi over 2. That puts me at -pi. And that's going to be at 0. Add another pi over 2. I screwed that one up. It's not -pi over 2. It's -pi. Sorry. And when I add another pi over 2, I get -pi over 2, and this one's at 2. So we're basically kind of the same idea of finding the 5 key points, except my first point and my last point are both asymptotes. I add the period divided by 4. And so now I just need to graph it. You got to pick an appropriate scale. Well, what'll work for this one? Pi over 2 will work. Okay, so I'm going to go, that means that I got -2 pi, -3 pi over 2, -pi, -pi over 2. Okay, now, and now I also have a vertical asymptote at -2 pi. And it hits at -3 pi over 2, -2, -pi 0, -pi over 2, 2. Since it's widened out and stretched up, it's eventually going to get to the asymptotes, but it doesn't have to go straight to them. Now I did ask for 2 intervals. Tangent, cotangent, I usually ask for 2. Make sure you leave yourself enough room to either slide it to the left or slide it to the right. Obviously, this one we want to slide to the right because I don't want to draw anything to the left. So just finish that up. And let's see here. And then it goes from -2 to 0 to +2. Now, normally for tangent, it has a vertical asymptote at -pi over 2 and pi over 2. Okay, and it hits 0. But now, since we've shifted everything and changed the period, it's been moved. All right, not going to have time to give you homework. So we'll finish the rest of this tomorrow as we go through here.
Actually, it's like 2 years old, I think. What is? I think I used to toenails. I mean, I only did a couple pages, so I didn't. My math book. I don't know exactly how old it is. It doesn't have the other math in it right now. It might have been for a while. I don't think it was. I actually agree.
Zone out.
No, because it was a math. I think
For the last test?
I don't know. She goes there.
Yeah, oh, were you? Ooh.
Like 8th grade. I don't know. It's an old one. Yeah. Well, I was guessing. Yeah. My favorite math. Oh yeah. I miss her.
How do I sit?
In a sense, like not really, but what? No. Tom. As a person. Those Romeo and quizzes? No. Don't miss those. Those are the best. Well, yeah, I know, but yeah.
All right, we'll see you guys.
Yep. To be fair, I learned more.
Mr. D-Lab. You want me to
Well,
come back
I
quiz I missed
more for
tomorrow?
myself, teaching myself.
Yeah.
No.
Alright. Can I do that second period? Does that work? Thank you.
Yeah, let me finish a couple things here. Let me get this put away.
Have a good day, Mr. D-Lab.
See you, Ryan.
Yeah, I know. And I know, that's so easy.
Done?
Yeah, only have to fix 2 problems.
All right, thank you.
Thank you.
No problem. All right, Kayla, let's see what you got.
Hi. Whoa. You lost? Am I in
No.
trouble?
No, I just wanted to talk to you because I miss you so much.
Let's talk. Kayla, listen.
Yeah, no, it's about Friday afternoon. You
Friday.
got practice 3 to 5, right?
Yeah.
Can we, what?
Go ahead.
Would it be okay if we pull the score side, like where you guys would sit, or do you need the full gym? If we would pull it, I would pull it before practice so we don't interrupt practice.
Okay. I wonder if we could get, we could maybe, I don't know, would it be too much trouble to get maybe till 3:30?
Oh, no, that's up to you. What
Okay.
it is nobody's gonna be here.
Right.
And so that was the whole idea was, because of the game, since it's the calamity game, and having guys come in at the not at the last
Right.
minute, but
I'm just trying to think,
it's totally up to you.
right. How about we get, first half of the practice? How about till